In 2023, the landscape of artificial intelligence took a giant leap forward with advancements in neural networks, enabling machines to learn and adapt at unprecedented speeds. This isn't just a theory. Companies like OpenAI and Google are already leveraging these systems to improve everything from language processing to image recognition. Neural networks mimic the human brain's architecture, where layers of interconnected nodes process information. By simulating this complexity, machines can recognize patterns and make decisions based on data input, fundamentally changing how we interact with technology. Understanding how neural networks function reveals the technological marvel behind their learning capabilities. At their core, these networks consist of input, hidden, and output layers. When data is fed into the network, it passes through these layers, with each node adjusting its weights based on learned patterns. This process, called backpropagation, continuously refines the model's accuracy. The history of neural networks traces back to the 1950s, when pioneer Frank Rosenblatt developed the perceptron, an early artificial neuron. However, it wasn't until the resurgence of interest in the 1980s, spurred by advancements in computational power, that neural networks began to flourish. The 2012 ImageNet competition was a watershed moment. A deep learning model trained by Alex Krizhevsky and his team reduced the error rate in image classification from 25% to just 16%, signaling that neural networks were not only viable, but were on the verge of revolutionizing technology. Imagine a classroom in the 1980s. Students are gathered around a dusty chalkboard, scribbling equations and methodically feeding data into rudimentary models. Fast forward to a bright, sterile room in a modern tech hub. Engineers are encircled by towering screens, algorithmically processing terabytes of data within seconds, and the very fabric of reality is shifting. Neural networks have evolved from simple mathematical exercises to complex systems capable of performing astonishing feats. For instance, Google's AlphaGo utilized a neural network to defeat a Go champion in 2016, showcasing its ability to learn and strategize in real time. Its victory over Lee Sedol, a 9-dan professional Go player, was not just a win for AI. It was a demonstration of machine learning's potential to tackle problems of immense complexity. AlphaGo achieved this by playing millions of games against itself, analyzing board positions and strategies, and constantly refining its approach. "I never expected to lose," Sedol admitted after the match, highlighting the profound implications of a machine surpassing human intuition and skill. Similarly, facial recognition systems in smartphones rely on convolutional neural networks to identify users with remarkable precision. Picture a bustling urban street, where individuals walk past one another, each face a unique combination of features. Amidst this sea of humanity, a device can recognize a specific individual in mere moments, unlocking doors to secure information with just a glance. This technology, however, is double-edged. While it enhances security, it raises privacy concerns that society must grapple with. The implications of these advancements extend far beyond gaming and security, reshaping industries like healthcare. Advanced neural networks assist in diagnosing conditions by analyzing medical images with a level of precision that outstrips human radiologists in certain tasks. For example, a study published in the journal Nature demonstrated that a deep learning algorithm could identify breast cancer in mammograms with an accuracy of 94.6%, compared to 88% for human experts. The potential cost savings and improved patient outcomes could redefine healthcare delivery across the globe. Autonomous vehicles represent another frontier where neural networks are redefining the landscape. Companies like Tesla and Waymo are employing sophisticated neural networks to process the vast array of sensory data from cameras and LiDAR systems, allowing vehicles to navigate roads with an increasing level of autonomy. Imagine a world where cars communicate with each other and their environment in real time, reducing accidents and traffic congestion while optimizing routes for efficiency. Yet, this technology also brings forth critical reflections on ethics and limitations. As neural networks gain capabilities, they face challenges such as bias and transparency. An AI trained on biased data can reinforce societal inequalities, raising ethical questions about accountability. If a hiring algorithm favors one demographic over another due to biased training data, the implications could be devastating for social equity. Moreover, The complexity of these networks makes them often regarded as black boxes. Decisions made within are not easily interpretable. As researchers like Timnit Gebru have pointed out, the lack of transparency in these models can result in unintended harm, especially for marginalized communities. What remains to be seen is how society will navigate these dilemmas while harnessing the potential of neural networks. The discourse around ethical AI is gaining momentum, with calls for diverse datasets, clearer regulations, and inclusive practices in AI development. In 5 years, we may witness AI systems that not only learn but also understand human emotions, transforming industries and daily life as we know it. This evolution will not come without challenges, but the potential to enhance human capabilities and foster innovation is within reach, waiting for us to harness it responsibly.